Okay, so our next speaker is Birkir Heimisson from Iceland. He has come here even though they are currently commissioning 5 digital substations at once, and so there's lots of work to be done at home, but he still took the journey to talk about it, so thank you very much. He's going to talk about digital substation rollout, the Icelandic way.
Is it shared or do you see the first? All right. All set? Everybody hear me? Okay, hi. So again, my name is Birkir, coming from Iceland, and I'll try to showcase a little bit how we have been implementing fully digital substation in the recent years. So again, the Icelandic transmission system, quite unique, often called the sandbox. We can try out these new technical things in a very closed-off environment. So that's why we've probably have been able to succeed quite in a recent year to these massive rollouts of digital substation technology. So again, we are going the fully digital way, going away from a wires over to the digital world. So, here. Trying to be based as much and as closely to a 6150 standard as possible, and also trying to be multi-vendor to a certain extent, at least. Come on. Stop working now. All right. All right, so this is where we're going. We're taking a conventional substation and trying to modernize it. So you can look at it the simple way as I usually try to simplify things. We're taking all these different functions and trying to combine them into something, all in one kind of box. So if you look what's actually behind this is of course what we all know. There are different protections in different boxes. There are certain bay controllers, devices per function, really. So now we really want to go into having all the functions within the single IDs, then making the redundancy on top of that. But of course, building a redundant networks and process interface unit, merge unit, SEUs, all these acronyms we've been going through this morning. Again, looking a little bit into a function of this, we really want some of these functions to be within the same devices. Point of wave has come up. Usually you have to buy a separate box for that, but certain vendors have started to bring those functions into the same boxes, which is the nice way. Again, into the applications, the next step, of course, we can take in the digitalization is then virtualizing the ID kind of environment, putting a centralized virtualized environment in there, which is an easier step when you've built the kind of fundamentals with the process bus and infrastructure needed in that way. A little bit about the recap about the projects we've been doing. We are running voltage levels pretty much TSO, DSO, even though Landsnet, where I'm coming from, is a TSO, we go all the way down to 66, even couple based on 33 kV. So kind of a mixture in a small island where I'm coming from. But the kind of replacement strategy has been going from air-insulated switchgear into endorsed GIS equipment in recent years. You can see it on the top pictures. Why we're doing that? We live up in the north. We have to deal with snow, salty snow and stuff like that, which are prone to flashovers. In this journey, we've also taken a big leap to going with the LPRT solution from the measurement transformers as well. It has its ups and downs, great technology when you look at it, but it has bringing a lot of kind of early adoption problems. So in some of the bigger projects we have been kind of have recently tendered out, we actually had to step a little bit back and go back to conventionals. But I'm hoping still that the big vendors keep on that movement, even though, we just have to get over the hurdle of these first adoptions. This also applies for greenfield and brownfield projects. So we have a couple of retrofit projects coming up, and luckily because of struggles with top level managers in my company, we had to take a little bit step back. So some of the we are trying in some of the refurbishment projects is kind of hybrid solutions, but I'm sure I'm waiting for a result to really show, okay, you should have listened, you should have gone the fully digital way. You maybe thought you were saving some bucks, but yeah, you end up getting it in the back again. Again, looking at the spacing, of course, going LPRT, you can squeeze down GIS equipment, and of course, the control cubicles drastically reduced when going with process bus solutions. But there has been some feedback from our operational teams that we have maybe gone too far. There was talk about the housing before, a lot cheaper, but some of the housing has been squeezed so close to the GIS equipment that it's can be really hard to operate, especially if there will be some serious faults later on and we have to go and replace. There will be not much space to work with. But at least we prove a point that you can build a whole lot cheaper kind of substation with this approach. Again, we are evaluating its pros and cons with especially the refurbishment projects. But quick overview. This was January last year. At that time, we had in operation 12 fully digital substations, locations of the 85 in total. We had, unluckily, the last year was kind of a setback. There was a lot of delays in our project, both due to technical problems, the new delay, also just a supply chain with high voltage equipment and so. So many of the projects we were supposed to be commissioned last year has been squeezed onto this year. And that's the reason why I left my team back at home. They were fighting with the 5 commissioning almost at a time, and we can definitely not manage all of them at the same time. But that's kind of the fight and the chaos we are living in right now. So all the focus is trying to get them into operation and facing all the other red and blue flags in our system with sort of the projects in front of us. But why am I here talking? You should. Oh, sorry. A little bit. First, cultural change. Of course, this is not only technical. This is also, like has been discussed pretty much this morning. This is a lot about the human factor as well, and the disciplined human processes. We are moving away from the blueprints and the wiring diagram over to the SED files, so you can't take any shortcuts there. SED is the holy grail. You should keep that updated and make sure that this kind of a process work towards getting that as correct as possible. Because again, this is the documentation. This is the description of everything which is happening in there. Of course, a wider knowledge base for IT and OT, it's merging, and you hear a lot about talks within these utilities. Okay, IT should take care of these. We should learn more OT and then somehow figure it out. But I think this kind of merger is definitely coming, and its utilities has to find their own approach. There are new things like what I refer as emergency controls. Kind of in our scheme, we have everything fully digital, but we have this emergency control on the switchgear itself. That pretty much means if you can operate that, you're bypassing your synchro checks, interlocks, and everything. So that's a new culture for operational people. They are used to coming in, going into a mimic, start doing something. This is a completely new environment, and that's a kind of culture change we're rolling out there. Of course, I mentioned these barriers and child sicknesses with early adoption of this technology. We are just with that just do it attitude, though. We'll just have to face them and solve those issues. Many of them kind of requirement and standardization, we definitely have a lot of iterative phase for the last couple of years. We started out pretty basic and have been kind of improving those kind of project by project since then. And also, as mentioned earlier, kind of the field people are throwing away their old tools and bringing their like laptops with softwares and Wireshark mentioned or now test equipment to really debug kind of the issues which you are facing now. But again, went a little bit ahead of myself before. Why am I here? I usually look at me like this guy, if you know him. This is the architect. I usually stand up high level and ask for something crazy, but we usually have to roll kind of the implementation out to system integrators, contractors to really do it. So but I'm still here trying to describe at least the approach we're taking. Here's the classical, maybe even simplified the engineering process within 6150. For example, when we started in 2019, the only requirement we put in the tendering document, it should be according to 6150 edition 2, nothing else. So all the contractors early going on to these projects early on, they just went ahead, did the old way, tried to bottom up, but when they quickly realized that wasn't going to help, they really had to stop their project and start over from beginning. And from there, we just added in our tendering requirements, both it had to be top-down engineered and kind of the work with the ICD, it should come from a third vendor-independent kind of company. We saw a lot of issues at that time from the vendor kind of 6150 tools, so we put out the requirement. And most of the contractor and system integrator at that time went with Helinks in that regard. But again, we are not fully here yet. Kind of the SSD or the system specification tools, we haven't really had the time to really invest in that internally at Landsnet. So we are doing kind of the intermediate step. This is somewhat in this direction. So we have specified a whole lot. We have specified the data model, standardized signal list, very much in line with what has been discussed here this morning. We have added requirement document, implementation guide, configuration templates, and then we work quite closely through the project with the system integrators. We have these technical meetings, make sure we are engineering it in the way we want. So again, when we finally are ready and can adapt all the knowledge in-house again, we can start to look more into SSD and have a process more specified from the early on. But at least this has definitely worked, but it will definitely save us more time in the future where we specified from the beginning. Also, also discussed this morning, we are dominantly using like Hitachi and Siemens IDs, for example. And we know that these two different companies, they apply the kind of configurable data model or kind of the overlay on a data model in different ways. So we still haven't, we would like to get a little hands-on experience with how that would work for us before us creating our complete Landsnet data model before rolling it on. So most of this, what we have been doing is kind of adapting what these big vendors within our system have modeled, and we have adapted to that. So we'll see what the future holds in this. So again, just trying to follow 6150 with logical nodes, all this conventional for the switch gears protection. So we follow that strictly. And also kind of the device model. We want to keep the functions within the logical devices themselves. And then creating the kind of correct data flows between them. But it takes a little bit of time to get everybody on board with this philosophy. Just last week, I was going through a project which had, contractor has worked with us before, but was having some subcontractors helping. And all of a sudden, I was seeing a lot of data which is sourced from SCU, which should, for example, go with MMS directly to the HMI gateway. It was properly modeled here with even flexible models, but it still sent it through Goose to the ID and then GGIOS from ID up to the system. And you're just, no. Why would you do that? So again, just building kind of that philosophy, and also, while I noticed maybe we're not too clear in our documents on all these details. So I went immediately, did some to-do list into other requirement documents, making sure all this philosophy would be well documented. If there would be new contractors coming in along later on, that they should be able to read up on the requirements we really want to follow. Networks. Again, we went quite early on to move away from the segregated station and process bus. We have moved on to a kind of a single subnet within our substation now. There was a lot of speculations in the beginning. I so far haven't gotten the feedback that this is ludicrous to go this way, but at least for us, it has been a lot more helpful. And I believe when we take the next step to going into a virtualized world, that this architecture is a lot more suited. Again, just there's no subnet, we call it whatever, 6150 network or station bus, combined station process, whatever. Lately, we've been getting some new firmware upgrades for GPS clocks to get the time synchronization going. First, kind of the clocks we had didn't have a proper kind of PRP plus PTP mechanism. Recently, there has been some firmware released to allow that. So we've been doing a lot last year and this year to upgrade those and get the PTP structure in a more redundant way. And part of this kind of network filtering is a critical thing. So kind of the switches here should be network engineered. It's same like with wire to wire in old conventional. This is important. You don't want to flood your information everywhere. We have also been getting experience with SDN, software-defined networking in a couple of projects. That's really promising, especially for cyber aspects as well. Also just tailor-fitting kind of the network. It's beautiful there. There are some hurdles we just have to figure out. There's some new releases coming out there to make PRP networks better configurable, and we have to do some tweaks, for example, the test equipment, because these networks are secure by default, and you can't bring a test equipment trying to beat everybody else. So you need some tweaks to allow a test equipment to really be able to do all the proper testing needed for those. I will not go to all the details here throughout some quite more high level thing. One of the things we went for in the beginning with the digitalization was to go completely redundant, meaning completely redundant from control as well. But then realizing how much effort it would be with more intelligence in the gateways and HMIs to really deal with it. So we've taken a little bit a step back in that full redundant control. So we're looking now for, when you have a main 1 and main 2 kind of system redundancy, we're looking for the main 2 system to only be kind of redundant towards the circuit breaker, not every disconnector and earthing switch. So it's more about if there's a snowstorm and there's a remote substation, if something trips and something breaks in the main 1 chain, you should be able to control and protect everything redundantly from the main 2 system. And then we can take everything. We don't need anything fancy in the gateways and HMIs. We just take all the signals. There's a lot less signals from the main 2 part, and we can then take it up and process it in our SCADA system and everything sufficiently. Again, redundancy also is a rabbit hole. And also if you bring in the kind of light addition limitations in sample values. So when you have a more complex kind of double bus bar, you might maybe have different VTs on it, you have different disconnectors, so it becomes quite tricky on how you should standardize, so you're not always inventing the wheel in those projects. So that's one of the things we're trying to do, both from a kind of limited or LE kind of limitations, and also just if you had more flexibility in sample values and so forth, defining which devices should handle each kind of controls and measurement and so forth. Testing. So testing also mentioned earlier this morning is critical to get the FAT as perfect as possible. You reduce the time in the field drastically if you do your proper work in FAT. So we have a requirement now in our FATs that should be in kind of the Reykjavik capital area, and we are always improving. And one of the big tests with me now is to really standardize on the kind of frameworks and documentation through all the different chains of testing through our life cycle of the plan. Substation. Of course, system testing is a critical. Testing your 6150 SD engineering networks, redundancy, time sync, merge unit testing has been critical. We have been getting kind of first version of some of our PRT merge units in operation. Some of them say they're performing perfectly according to 6150, then you go and test it, and now they need some improvements. So we've been a lot of focus lately on working with vendors to really tweak their solutions. Then just increased focus on automation, if it's with signal test, if it's with interlocks, even your protection settings files. There's a lot of automation can really speed up things in testing. Because again, this is digital. If you do your homework before showing up site, you only have to press play and then leave it to it. Then you look if something is breaking and automate the test. Again, using test mode simulation flag, critical in this, and even more critical when you get it into operation, that we're able to do and work on the devices even under operation. So you can, especially if you have main 1 and 2, you can keep your asset in full operation and do a complete test on your system with this methodology. Same what we have defined. We have defined, for example, gooses from protection IDs, which have no subscribers. They were just including kind of every protection element in the IDs, so we can bring in our test sets and subscribe to those gooses for testing purposes to have all the details, not only listening to trip and start contacts. Again, done a lot of automatic signal verification for signal test, trying to make the computers make sure that it's correct, not by visually inspecting for many days or weeks the thousands of signals coming from there. And recently we've been looking a little bit about failovers and failures in HMI and gateways, making sure those are working properly. Here's an old event we had. After we commissioned one of the station, we were having islanding operation in our grid, so 2 islands, and we were supposed to close that island, synchronize it together in one of the new substation. And when we went in there and closed the breaker, it closed, and it closed on a 100-degree angle, leaving a massive shock to our system. And we just, what just happened? We went through a test report. Okay, the synchro check is working perfectly. Went on and debugged it a little more. Then we found a little bit of a pitfall within a switching control box within 6150. So there are these condition settings. So you can choose if you synchro check and interlocks, pretty much bypass them. And there was a glitch in the gateway we had there. So it was had the settings that it should get these condition settings from the 104 command coming from the control room. But when it didn't include it, it kind of dropped the synchro checker. So it bypass the synchro check while closing this. So we immediately realized that. We managed to go on site, did outheadless maintenance to really test this out. Again, used the test philosophy to just test it while being in full operation. And then we changed the settings in the gateway to, not do this inherited from a 104, just always leave it on, and then, work perfectly. So this was added to a test list, like make sure to get the control command directly from the control center under kind of condition where the synchro check should block. Again, into a signal list and standardization. This is a very high-level view of the signal list. We have some station signal, bus bar, then this different for each bay, and we used to send all these signals to the gateway HMI. That also included kind of asset monitoring signals, like the SF6 or the gas monitoring of the TIS, and lots of signals going this way. Same with all the protection monitoring included. What we've been trying to do also, mention also protection signals. We used to take them directly from source. Like if there's, let's say, overcurrent, and there are maybe we can have 1 up to 3 steps. We have to define each step really. So we need to customize the signals for every project, depending on what protection we're using. So and on top of everything, we are overflowing the dispatch with alarms which they even don't use. So what we've been trying to do lately is to simplify things. We are taking all these asset monitoring, we're taking it off this path. We're just taking it through IoT kind of approach, leaving all the kind of expensive configuration through the whole system, because we would get it to a SCADA system and then get it out of the SCADA system to really process it. Same with, we are always rethinking about the PAX monitoring, if it should always come from the source, or if the HMI or something should look at it holistically and then giving some group alarms up to the dispatch. And for the protections, again, we put everything in a contract file because we have a system to automatically fetch those and even do disturbance analysis. But we rather going to take kind of the general trips or the PTRC for each protection rather than to having to define every single. So we're trying to optimize the signal list slowly to make it, not as kind of changeable from project to project. Then last autumn, we hosted this digital day, first time in Iceland where the nerds were able to have a kind of conference within Iceland, and really trying to embrace kind of what we were doing in Landsnet and showing kind of the beauty of what 6250 and everything could do, and that really sparked some interest. And you have a couple of projects already now with DSOs and power producers in our system. So now we start to share data between, for example, to a DSO, they might own a transformer, and we only have a LPRT measurement on the other side. We could be sending them our sample values. They could have a conventional ID from their side, but with application to receive sample values. We've been able to exchange gooses and stuff like that. Only thing we just have to watch out for is that boundary here. We just have to make sure we make that secure. There we come in with your firewalls or SDN to really kind of tailor fit what's allowed to flow between the customers. So we have a lot of things kind of started to track attention in that domain. I presented in the last SD conference last year or year before about this concept, which we also want to achieve. It's a digital transmission system. Not only think about the substation themselves. We really want to step into the world where we can have substation talk to each other based on 6250. So that's kind of a dream. That includes kind of global, kind of land-based PDP with a time synchronized kind of telecommunication network. We could start to talk about MMS from a substation gateways to the SCADA system, getting away from 104, for example, and then sample values between substation for differential protections, goose messages between them, goose messages even wider sense for some more smart grid kind of functionality. So all of this is pretty much when you throw all these kind of legacy protocols in the trash and start to harmonize on 6250. So that's a plan. So for us as protection engineers, and for me as been working a lot with wide area controls and smart grid product, this is just the Swiss Army knife when I get this system. So I don't have to integrate always a new system on top. I can have this powerful telecom system which kind of shares the data between. What we have in mind, I stole this from Hitachi because we are going for a solution from them for the pilot of this thing. We're working with our daughter company, which runs the telecom for us, and we're working for a new kind of telecom infrastructure for this. So we're going to be testing out the Fox system there. And this is the approach they are going for. I'm not sure if this has been discussed in depth within the industry itself, but this pretty much is the SED kind of work you need to do. You have, of course, multiple substation. Here's this example, substation A and B, and this is a little bit of ping-ponging. Of course, you're taking a complete SED files and you have to integrate them together. So there's a little bit of interaction where you have to define like proxy gateways in there. You create kind of the virtual IED instances kind of in each substation to really map kind of the sample value and gooses between them. So this looks complicated here. When you get down to it, it's kind of, it gets straightforward, but of course a lot of work. So it will be interesting just to see if this will be more widely adopted in the future, if we manage to do this maybe with a more simplified approach and maybe complete top-down approach from the beginning, because again, this is a little bit of top-down, but then a little bit of ping-ponging by integrating the different substations together. Again, the proof of concept project in Iceland is like with 5 different nodes, including a central node with being a grandmaster for the network. So this is what we have on. We have a telecommunication equipment now. It's a little bit behind. Again, it's a development project and we've been quite busy, so it hasn't been moving as fast as possible, but we are going through some training with our telecom provider now in the springtime. So hopefully by the end of the year, we start to have some of these kind of set up in the field for the first field trials. And it's funny because we're building this in the middle of that kind of volcano activity has been all the news lately. So it's quite a hot spot. again, just final kind of, I mentioned this, we are really looking into this concept in the near future at least. We need maybe more of these kind of market-ready solutions from at least the vendors we're used to work with. And we can always start kind of, for example, main 1 and main 2 requirement substation. We could have conventional from main 1, but the main 2 system could be virtual. So when we have all the infrastructure ready for this, I think it will be kind of not too hard to start to implement those on top when we gain a trust and experience with this environment. Finally, just some random thoughts about SEDs. Kind of the SED lifecycle itself, we still have to overcome a little bit of the kind of fear of modification. This seems like there's no problem while this is being commissioned. Always when it has been commissioned, there's a little bit of a fear because there are some upgraded firmwares all between. So, but we have to get kind of adopted, manage it, and and also work with SED maybe between different ecosystems even. And again, kind of SED issues that mostly the contractor has been facing, and I've heard a little bit about, is something I just want to mention them. Kind of sometimes same signal has been set in 2 data sets or controls sent to a same subscriber, and some of the tools have maybe missed that. They're not notified. Okay, this is not right, and then the end device stopped subscribing it. So kind of a hidden feature. Configuration revisions. Kind of maybe some element that should really be paying attention, but some tools, both of course at least ICT tools, they sometimes step in and start to change those even though there are no changes, and that creates a massive hurdle having to update everything and stuff like that. So managing the configuration revision based on the changes between the version is critical. It also applies maybe to firmware. So maybe it's overkill to have your firmware with the device, all the communications are unchanged. Is there a necessary need to upgrade the SED and roll it out to all the devices? Or can we somehow update the SED without having to roll them out to all the devices with the disruptions? There was some case one time about MTX ref blocks that, again, with the ICT tools, they got in a SED file, no problem, everything looked fine. You loaded it to ID, and ID just went to like a froze or didn't do anything. No error catching, nothing really grabbed this. So it created weeks of trying to find out the solution of it. So and stuff like that. Some of the legacy merge units also have outdated kind of models. So in some cases, we have had to do just adapt the data model just for test sets and everything to work properly. Controller has been having trouble sometimes to take 6050 and numerate signals to get them over to 0.104. So there's a lot of tweaks there, and sometimes that usually gets messed up and needs some tweaking. And kind of ICD files for the gateways, HMIs, are usually some made-up files, and in some tools they complain about them because they aren't kind of correct. So my kind of thought to throw out here was improved validation, I said, both in SUT tools and especially ICT tools about all this problem, making it, at least for end user, more descriptive, more kind of pointing towards the problem. So it will be kind of, from a user point of view, a very nice feature. And this talk in a previous chat about some more structured kind of, what was it called, OCL. Maybe that's the way forward, maybe, to at least for the vendors and everybody to pay attention to this, to catch the errors and the fault in configuration early on, not just rolling out to the ID and then the ID stops working and you just, what's going on? Just wrapping up MMS, we recently found out that many of the signals were being pulled instead of reported. That's particularly bad for protection signals. And we've been kind of trying to find out. One of the issues is, I think, that the contractors, because they usually take care of that and we haven't been paying attention to it, they may be, in some cases, haven't been doing a complete top-down engineering towards the gateway and HMIs. So they do some old manual work to really get that working. And in some cases, this philosophy might break some of the subscription elements, and then the devices start to pull the data instead of having it reported. So having a reservation for the cybersecurity and just having it checked. Indexed reports have sometimes been kind of problem. We have always kind of wanted to do it really statically and define it exactly. And then I think in the standard it says if it comes from a SCT, it has to be indexed. So some of that has caused these pooling and reporting issue. And maybe we're old school in that, as some of the vendors allow this dynamic reporting, but we really want it to be statically. We really want to define it down to our tailor-made solutions. So usually we have to go and disable a dynamic function, and we can disable it completely. But at least our approach has been this. Final comment here is just for the SDN kind of software-defined networking. If the test equipment itself should be modeled, just to allow the easier configuration of the SDN networks. What is a test equipment? How should it be configured, validated, so it can be connected to that secure networks and able to do the simulations and stuff like that it's supposed to do. A lot of talking, but final slide, just system thinking rather than modular. So top down, that's our approach. This is just a summary of which you could read afterwards, but just learn by doing, just doing it approach. Of course, easy for a small utility to say that, but still, just go out and make a 650 come the day-to-day business. Again, just it comes down to a human factor. We're always improving and iterating, so mistakes are just part of our journey. We just keep on iterating our implementation, documentation, requirements, and so forth. And all this new technology, of course, inter-substation communication, virtualization, more increased hyper and WAN connection as well. So yeah, I think that's it for me. A lot of speed talking.
Thank you very much, Birkir, for the presentation. And are there any questions? Yes, Andy.
I think you kind of covered off on the end there, but do you think that the test equipment should be included in Helinks as an IED almost? And do you think it'd be useful if the test equipment was treated the same where it was publishing and subscribing information, possibly with some kind of functionality to turn that off and on? So turn it on for a commissioning period, then turn it off again once you're happy that that's done, so all that information then comes out of the SCD file.
Exactly. I think it could be a way forward, especially if you don't do that. You always need your hands-on tweaking when configuring software-defined networks. So you need to do all this extra, like this device can't come in here. You have to define this and this just to get connection, and then you want to simulate all the rest of the IDs. And of course, the switch will not allow it. It might allow it to connect to it, but trying to beat everybody else simulating, I think something needs to be tweaked, and I believe adding that into SCD could be a way forward to implement that. Because, again, while we're doing all this digital, the cybersecurity requirements are getting higher and higher as well. So having such kind of secure networks is the way to go, but then you can't make your life miserable in testing without finding a good solution for that. So yeah, definitely.
And then also, to what extent did you do automation tests with any of the tools that are available? Did you look at test automations to validate your signals?
You mean, sorry, for signal, like signal testing?
So signal testing, or for example, Station Scout, where you can do the 104 testing and have that kind of closed loop test with all your system.
Exactly. Yeah, we definitely do that. Station Scout is the key word here. It's now we have added requirements on the contractors, so they can do kind of closed loop testing from simulating all the 1650 signals onto the bus. They can monitor the 104, validating that to the signal itself, so they can validate everything before we even get to FAT. What I've been doing extra is looking at our SCADA system or dispatch SCADA as well. I'm able to fetch kind of a configuration of that, validate the configuration beforehand there. So we do checks on both ends, and then in the end we go and connect everything together. We simulate all the signals in the system from 1650. We get the event dumps from the HMIs at the station. We get event dumps from the dispatch center, and then we kind of merge, compare those. And that's a brilliant thing rather than to use the visual eye, which has been done for decades, taking endless amount of time. And now we can just get it compared. Again, this is computer. It doesn't allow any margin of error. Like if there's access at white space or if there's typo, it will grab it. So, but I think in the end it will be good, and it will drive the contractors to really kind of engineer the way properly from the beginning. So.
Okay, thank you. Are there any other questions? Yeah.
Yeah, you talk about you have your vendors or your engineering parties, they make these mistakes. We heard part about supplying templates or libraries to the vendors. How do you, what do you supply your vendors, and did you look into how to prevent these mismatches or mistakes between your specification?
You're more talking about the system integrators,
yes.
Right, yeah.
Yes,
exactly, yeah. As I showed in the beginning, we just put out these kind of requirements, different requirements, not like a SEL file, SSD file. This is how we want it. So we give them these templates of signal list, we give them all this kind of documentation. Many of the contractors who have been doing projects before, so they can template something from their previous projects, for sure. And we are always improving those kind of documentations. So they're in different format again, but it's more kind of pointing them in the right direction, and then this collaborative work. So there is a little bit more overhead on the system integrators to build up the SED file itself, rather than getting it and then just implementing the kind of virtual IDs in that file. But again, it has been going quite successfully for now. But again, all these little tweaks which are time consuming, which we are always trying to polish to get kind of more smooth in the projects following.
But this is a specific choice you made because you want to keep your system integrators. Also, you give them a choice in which type of vendors they use, or why do you make this choice instead of supplying like Helinks templates to your system integrators?
I think it's a matter of resources, actually, from us. More kind of this is definitely a long-term kind of benefit, but we're usually fighting in the current situation. So we want to get there. Don't get me wrong there, but at least at the moment we haven't been able to do all that kind of us stepping away from a field and just going in the lab, getting familiar with what I talked about before, different approach from different vendors, how they implement kind of a complete top-down engineering data model and stuff like that. So we would like to get our hands a little bit into that and knowing it before out just rolling that out and leaving all the mess to our system integrators to deal with it. So yeah.
Okay, thank you. Any other questions? Yeah.
You said you ask your contractors to do top-down engineering. How do you check it? How do you know if they do it?
They found out the hard way, the first project, as I mentioned. They tried what they knew to go bottom up, but in the end, they were just, this ain't working. So they had to take the hard choice, just delete all, start from beginning. Where do I get Helinks? Where do we start this process? So, of course, we don't have a validation for it. As I mentioned, they had probably gotten away with how they configure the RTUs and HMIs for quite a while now. Mm-hmm. So in the next release of our requirement, we're going to add that in the requirements. How we check it is pretty hard, but that's pretty much we giving them the information. There are better ways to engineer this. I know you're used to something else, but go ahead, educate yourself, figure out how you could do it in a top-down approach. So that's the best thing we can do without having to be there with a kind of showing them exactly how they do it. So it's tough to validate, I would say. But
Okay, but you also mentioned that there are better ways to do it, and you're trying to teach them that there are better ways to do it. I'm pretty sure that the teaching is not just one way. They also tell you that the way that they are doing is the best way to do it.
of course.
So how do you overcome that?
We might be sitting in a driver's seat, and I could put the requirement down that they should do it. So, but I think they get the point
Okay.
in the end. So, kind of with everything, we've been teaching the whole way about the testing methods. They've been testing it always the old way, just going through a source. They don't know how these test modes and simulation work. When we actually come there and do FAT with them and to see what they're doing, now try doing this, and they're learning on the way, and then the light bulb hits. Oh, okay. So everybody is learning. So it isn't, it's especially for system integrators who are really doing a job. Again, I'm just an architect on top asking for all these crazy things. So it just takes a little bit of time and for contractors to really grasp the possibilities.
It also
of
always
this.
begins with one crazy idea, right?
Yeah.
You also mentioned about virtualization, and you're thinking in that direction. And in the near future, what is near future then?
I would say it depends a little bit about our main vendors. Kind of, we are, again, from our protection IDs, we are pretty much with Hitachi and Siemens. Those still haven't come out with a commercial release of that. There's something, they talk about it, but when those are released, we can start to test those devices, and then as I say, we have a good foundation to start in baby steps to implement those. And we could, as of today, if you bring out the server with all this, we can configure it for a station. We can go and hook it up passively to a network easily. And then we can monitor it passively for a while, and then just start building up trust.
So your idea is to just have a parallel system right now, build up the trust, and then move in that direction.
Pretty much, yeah.
Okay.
And of course, you need to build up competence with us within the contractors. Virtual world is a whole lot different than having the kind of hardware IDs. So that will, I think, the time will tell. Hopefully, I'm not talking about decades. I'm talking about, a couple of years at most. So.
One last question from my end.
Yeah.
Right now, everything is turnkey project delivered by a system integrator. Have you also thought about maintenance, renovation? What if you have to add additional bays?
That's always kind of for bigger projects, adding base and stuff like that. That's always the contractors coming back in. Then it just depends if we make a deal with a contractor who recently been there or not, or we just tender it out as well. So that's kind of the approach. We don't have the resources or the manpower within Landsnet to really do the actual projects. We are more, but we come and test it and operate it and make sure fault analysis and everything which follows. We do the maintenance, really. That's also training kind of the field crews into that topic as well. That's also just taking time, but I think that's our approach.
Okay, thank you.
Yep.
Thank you. I think Jackson, you had a question, right?
So I have a few. That's okay. First, gateway redundancy, not redundancy of the gateway, but redundant devices passing into the gateway. You mentioned that there was some complexity there, and that was one of the reasons you shied away from having redundant IDs at every level. I was just curious about what those challenges were.
I think it's more about kind of if you have a device and you have maybe for a complete control, you might have 200 signals. You make a main 2 and you bring another 200 signals, and our SCADA system operators don't want to have 400 signals for that. So there was a requirement, if you were going to do that, you would have to have the selectivity functions. So there would be a single source kind of sent to the dispatch center, and just having this logic to really, choose between kind of a rabbit hole situation with engineering. You can make it the best one in the world, and it gets really complicated. So we got kind of spiraled down that direction. So then we just started to think about it, kind of what are the chances that we need everything completely? You would need the double wires and connections as well. Then that's just brought in the idea, okay, why don't you just focus on a circuit breaker itself? And for kind of what we have seen so many times before, there are some big snowstorms, there are faults, there are trips, and all of a sudden some breaker doesn't kind of want to be controlled due to control issues. So at least we should focus on that to use it in those circumstances, not and it's kind of probably far into the future, we're going to do a whole lot of disconnected switching or earthing switches without having personals on site for that. So that was kind of the story where we went with.
And then another question, you mentioned, I think if I understood correctly, you guys were looking at wide area applications potentially for protection where you're looking at sending goose between substations.
Mhm.
Are you looking at using routable goose for that? And if so, are you interested in authentication and encryption, or will it be on a dedicated network for both?
So far, as we are a TSO and we have our dedicated kind of black fiber networks, really. So we have it so closed up. So we are looking again, as this pilot project is doing, is looking at just conventional one, because this MPLS system can't just kind of route it, even though it's not routable. It's still on layer 2. I would say if we were going to do something with DSOs or something where we don't have an endpoint in a communication, we have to go through something else. That's maybe application we would use routable. And then if in the future kind of routable is, kind of topping that it's a better choice, for example, while using stuff like that, then it's something to look at. But at the moment, layer 2, sample volley and goose on this MPLS networks.
And last question, you talked about the exchanging of SCD files between multiple substations. I've heard the term SED file. I don't know much about it. Is that something that you guys are looking into?
Yeah, I'm hearing it the first time now, but pretty much this approach I was showing was pretty much you have SED, which is kind of from the beginning kind of meant for the substation, and now you're sharing between SEDs. So you pretty much just have to kind of integrate those two SED files together, and that's done with this proxy gateway way, still a SED file. So that's again, if the industry has a better approach and this becomes part of the future wishes from our utilities, I bet we can probably optimize kind of this engineering from a CL point of view.
Maybe to speak to that, so at the SED file, you can exchange certain parts of a project, import them into another project, and then subscribe to the IEDs that are in there. So it might be useful to check that out.
Okay.
And I just want to mention that in SDS, you can also have multiple substations. So you could theoretically start building something like that if you wanted to. Yes. I have also some technical question. Are you thinking about incorporating 6150 in your network configuration? So having switches that are configured by an SCL file and working with the vendors, or is that something you're not considering right now?
As I mentioned, we have worked with Schweitzer for their SDN networks. They use, of course, the SED just to see the endpoints and how they communicate. There are other, I think many of the other switch vendors, conventional switch vendors, they are making tools to work from SED file as well. It really, of course, it's more of a static way of thinking. If you're going to model your switch, and you're going to model where it's actually, if it's connected to this in this port. SDN at least does it really well. It will learn where the devices are and configure the ports completely from there. So it really depends maybe on the kind of switch manufacturers, conventional ones, adding some add-ons to their tools to adopt that. Which one is better? So maybe option to do it for sure. That would need to get ICD files for the switches and stuff like that. So probably options is there, but there might be more optimal way to do it, in my opinion.
Okay, thank you. Are there any other questions?
Yeah, just to kind of follow up with a question on redundancy. So we found the same as you did. We tried to go down the redundant route, and it got to the point where you were actually adding additional engineering to overcome a problem that was probably quite unlikely to happen anyway. So yeah, how do you send one DMP3 address command to two 6150 endpoints? You need some kind of logic in the middle there to handle things like that, and likewise going back up. You may be able to do something in the HMI, but we found that the control room top end was even more antiquated and wouldn't be able to send 16150 point to kind of two DMP3 addresses going up the other way. So you end up with too much duplication and trying to achieve redundancy, and it makes it not worthwhile. I think there's 61850 90-20, which is going to try and add some redundancy functionality into the standard. We've also found IEDs don't work as kind of primary, secondary servers like PLCs do. You don't have a main and a standby with IEDs. They don't talk to each other on that level. So you can't really have an IED that's being the master and another one waiting to be the slave. So to solve all these issues, you end up by just adding too much complexity to try and do it.
Keep it simple, isn't? Wasn't it
and
engineering?
Sorry, just on the switches point of view, we would be interested because things like SNMP are really difficult to configure outside the standard as well. It would be great if the network switches were an IEC server and you could just pull that kind of port information that you usually have to get through SNMP or some other means from the switches via IEC 61850. So we're trying to encourage whoever we're talking to about switches to make your switches 61850 aware so we can get information from them like that as well. They're already connected to the PRP network, so if they had a simple server running there to get that information, it would be useful.
Yeah. Good input.
Okay. Thank you. Any other questions or comments? And nothing on. Oh.
One last one. So you mentioned reservations. You just had it as a blurb on your that things to think about. That's always been a topic that's I found confusing because from what I understand, servers don't enforce reservations of report control blocks. I believe it's up to the client to just know or not reserve a report control block that it's not been reserved for. Do you have any comment on that? I was just wondering what were the issues that you guys were having with reservations?
Pretty much we found out one recent project that we saw that the client wasn't getting reports. It just was pulling the data. But to get access to a report, we tried to take out the reservation. We took it out from SED file, just this connection, and threw it back in there, and then it worked. So there was some kind of functionality between the different versions of our HMI and the ID we had at that time, which kind of was breaking. So that's what I'll set in kind of what we had set in our test process now, is making sure everything is properly subscribed. Pretty much test if your reservation is working. Again, it's up to a client to allow the server to allow the connection right, but I'm not in the full detail. At least it wasn't working. So just making sure it's kind of tested and then figure out if it's not. And in this case, we saw reservation was the problem. So we tried, I think it was just to patch, I think it was HMI system, and then it worked after that. So it's into those kind of things. Pretty much go on to your network, monitor if you're seeing pulled or reported data, and then you can track down why that is happening. That's kind of to a testing philosophy for field engineers.
Then thank you very much, Birkir. If there's any more questions, and let me check online. No questions online. Okay, then I think a round of applause again for Birkir.
Thank you.
And let's not forget the cheese slicer, courtesy of Spee, and the cutting board, of course.
Oh, yeah. Great. Thank you.
Okay, now we have a slight delay, but we do have the room until 6, so I think we can still do a coffee break now, right? Yeah. I can speed run it. Sorry? Should I just pull out my slides now that I was going to finish in the coffee break? That's